So now that we have these different numbering systems, let's look at using them the same way we use decimal. So I will, just to be as insulting and as possible, I'll give you a little example of addition using decimal numbers. So let's try 315 plus 218. So we should all recall 5 plus 8 is 13. So we put the 3 down here and we carry the 1 over. Now, here's the key thing that we want to take away from this. Why does it carry over? Because the value is greater than it can be represented with our base. With base 10, if we ever get a value bigger than 9, we need at least 2 digits to represent it. So we had to move that over. 1 plus is 3, and then 3 plus 2 is 5, right? So that's our decimal addition. Pretty straightforward. Well, guess what? Binary, just as easy. 1101 and 1001. 1 plus 1 is 2. We cannot represent 2 in binary, so that becomes a 0 with a carryover of 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1, again, is 2. We cannot represent that. So we get 0, and we carry that over. So we get, our final value is 10110. Works out exactly the same. I'm not going to do oct, but I'll do hex for you really quick. Let's do 05A plus 1, 1. Let's do B here. All right, we add those. A plus B, which is 10 plus 11, is 21. Right, it's a little bit tricky, but it's not unintuitive. 21. Remember, we can only represent up to 15, correct? So we have to carry over 16 of it and subtract 16 from 21. We get 5. And then we have 1 plus 5, which is 7, 175. And that's base 16, base 2, base 10. So, addition, pretty straightforward no matter our number system. Okay, well, how about multiplication? Again, let's go back to what we understand, decimal. And let's say we have 212 times, just to make this easy on myself, 22. Anybody remember how to do long division? Right? So 2 times 2 is 4, 2, 4. And then we add a zeros place. And then we have 4, 2, 4. Add them up, we get 4, 6, 6, 4. So binary multiplication works exactly the same, but it's actually a little bit simpler. So let's do 10101, multiply it by 01101. And again, we start all the way from the right, but because binary is always 0 or 1, really all we have to do is copy that number down and shift it over to the appropriate number of places. So let me show you what I mean. 1 times 1 is 1. 0 times 1 is 0. 1, 0, 1. Now, because this is a 0, this whole thing is going to be 0. So we can just ignore this next step because it's just going to be 0 and then a bunch of zeros shifted over. So that's pointless. Shifted over 2, we're going to have, again, because this is a 1, we just copy this over. 1, 0, 1, 0, 1. And then we shift it over 3. 1, 0, 1, 0, 1. And the last one is 0, so we can ignore that as well. We just add up what we have, and we get 1, 0, and this is 1 plus 1, which is which is 2, which we can't represent. So we get 0 with a carryover of 1, and this is 2, so we get 0 with a carryover, and this is 1, 2, 3, so we have a 1 with a carryover of 1. Oh, and that's 0 with a carryover of 1, 0 with a carryover of 1, 0 with a carryover of 1. So that's our final value. So multiplication for binary works exactly the same as the way it works for decimal. And when you take CS51 in the spring, we'll talk a little bit about how we can actually use adders to make very fast multipliers using this principle. Division, much the same system. So let's divide 35 into, let's say 412. So obviously 35 can't go into 4, so it goes into 41. It goes into that 1 time. 1 times 35. 1 times 35 is 35. Subtract that, we end up with 6. Bring down the 2. 35 goes into 62 1 time. 1 times 35 is 35. Subtract, we get 27. So it is 11 with a remainder 27. Alright, by the same token, if I have 101 and I'm dividing that into 1000101, works exactly the same way. We have 101 cannot be divided into 100. It can be divided into 1001, and this is where it's counterintuitive, but it's because we're not used to thinking this way, but it works. So you should be able to figure this out on your own. Essentially, this is 5 and this is 9. So 5 goes into 9 how many times? Really 1 time. And again, we multiply 1 times whatever is itself, so we get 101, and then we subtract, and what is this right here? Well, 100 is 4, right? Which makes sense. 9 minus 5 is 4. So everything is working out the way we would expect at this point. Now we just need to bring down the numbers that are left. Now we just need to bring down the next number. We have 100, which, if you should be able to figure out this right here, that is 8, right? Can 5 go into 8? Yes. How many times? It can go into it 1 time, and then we're going to multiply and subtract 101, and we get, when we subtract, remember we're subtracting 5 from 8, what are we going to get? It's going to end up being 3, right? Then we bring down the next value, 111, which is 7, right? Can 5 go into 7? Yes, it can 1 time. And then we're going to, again, multiply 101 and subtract. We get 0, 1, 0. So the answer is 7 with a remainder of 2. So I should put this up there. Remainder, running out of room, 1, 0. Which 1, 0 in binary is 2. So the key thing I want you to take from this is the process is exactly the same. It's no different. Whether you're doing multiplication, addition, division, whether you're doing it binary, hexadecimal, decimal, you're just only used to seeing it in decimal, but it's exactly the same no matter our base number system. All right? If you have any questions, ask them in the forum below.